For the first part of this reaction, we need to make oxygen gas. To do this, I added potassium iodide to concentrated hydrogen peroxide, creating oxygen, which bubbles through the tube and into the water-filled flask. The oxygen displaces the water, filling it with pure oxygen. When it was full, I pulled out the tube and plugged the opening with a cork. Next, I scooped out some sulfur beads, and notice how the sulfur is yellow. This means that it is absorbing blue light. I lit the sulfur on fire with a blowtorch and we removed the cork and replaced it with the burning sulfur. The sulfur vaporizes and reacts with the oxygen and burns a brilliant blue color. It burns blue because it is emitting the blue light it always absorbed. For the elephant toothpaste reaction, I poured 50 milliliters of 30% hydrogen peroxide into a graduated cylinder and then added some dish soap. I then added 8 grams of potassium iodide. This is actually the same reaction that I did in the last experiment. However, instead of trapping the oxygen in a flask, all the oxygen bubbles mix with the dish soap and creates foam, making it look like, well, elephant's toothpaste. An endothermic reaction is a reaction that gets colder as it proceeds instead of heating up like most do. For this experiment, to start, I added some water onto this wooden board. On top of that, I added a beaker filled with 32 grams of barium hydroxide octahydrate and poured in 11 grams of ammonium chloride. I then mixed the two together for about a minute and ice crystals began to form inside. When I tried picking up the beaker, the water I had put in the beginning had frozen the block of wood and the beaker together. For the Briggs-Rauscher reaction, I need to make 3 different solutions. For the first solution, I mixed together 500 milliliters of water with 22 grams of potassium iodate and 2.3 milliliters of 98% sulfuric acid. I mixed everything together with this magnetic stirrer and poured it into a jar and capped it off. For the second solution, in a separate beaker, I added 175 milliliters of water to 0.2 grams of cornstarch. I mixed it together thoroughly and boiled it in the microwave to make sure all the starch was dissolved. In yet another beaker, I mixed together 325 milliliters of water with 1.7 grams of manganese sulfate and 7.8 grams of malonic acid. Once everything had dissolved, I added the cornstarch solution to it. Once the mixture came to room temperature, I filtered it through a coffee filter several times to remove any excess cornstarch and then capped it off. And finally, for the third solution, I mixed 200 milliliters of 30% hydrogen peroxide and 300 milliliters of water. Now that I have all 3 solutions, I mixed together 200 milliliters of the first solution and 200 milliliters of the second solution and turned on the stirring. And finally, for the magical moment, I added 200 milliliters of the third solution. The entire mixture turns yellow, and then, boom, it turns a dark blue-black color. The solution begins to lighten in color until it turns clear again. Then it goes back to yellow, and then back to a dark blue. The reaction oscillated back and forth 9 times before it stopped. The Briggs-Rauscher reaction is one of the few known oscillating chemical reactions. I also did the reaction without stirring in a graduated cylinder by adding equal parts of all 3 solutions. This causes the change to dark blue to be much slower and spread through the cylinder. And finally, sodium and water. All I had to do for this reaction is throw a chunk of sodium metal into a glass of water. The sodium fizzles around on the surface until, bang, it explodes. The water molecules violently rip away the outside electrons from the sodium atoms, causing an explosion.